We live in a messy, unpredictable world, yet we attempt to navigate it using sterile, rigid data. But every researcher faces the same foundational problem. You cannot accurately measure a variable that you haven't yet conceptually defined. To solve this, modern research relies on a dual engine. Qualitative methods generate new theories by observing human context, while experimental methods test cause and effect through rigid environmental control. We are going to map the exact architecture researchers use to move from subjective human observation to statistically validated causality. This pipeline is essential because the trade-offs made at each step determine whether a model built in a dashboard will actually replicate in a physical marketplace. Every formal inquiry starts in the dark. A researcher enters an underdeveloped topic where no clear variables, categories, or metrics exist yet. Qualitative research operates as a specialized tool for deep exploration, identifying structures where no defined variables yet exist. This chart shows the inductive logic loop. Researchers start with raw, unstructured observations, identify recurring patterns within that data, solidify those patterns into concepts, and finally generate testable theories. To extract this raw data, researchers deploy specific methods. Individual interviews are used to gather deep personal insights and subjective meanings directly from participants. Focus groups take a different approach, designed specifically to reveal shared meanings and group social dynamics through real-time interaction. And when physical, real-world actions matter more than what subjects verbally claim, researchers rely on direct observation to watch behaviors naturally unfold. Those are primary sources. Researchers can also rely on secondary qualitative data, repurposing existing corporate reports, press releases, or digital content to answer a completely new question. Because this entire phase relies heavily on subjective human interpretation, it is highly vulnerable to both researcher and respondent bias. Qualitative research is the inductive engine of discovery. It creates theory and identifies potential value, even lacking the mechanical structure to definitively prove it. Once a theory emerges, it leaves the inductive loop and enters the rigid testing chamber of deductive experimental design. Here, the core rule is simple. Simple correlation is not strict causation. True cause and effect relationships must be actively isolated and manufactured. The first mechanical requirement of causation is manipulation. The researcher actively creates different levels of an independent variable. By adjusting this dial, the researcher measures the direct effect on a dependent variable, establishing a clear mathematical link. The second required action is randomization. Participants are assigned to test groups so that each individual has an equal chance of selection. This random sorting takes external nuisance variables and spreads them evenly across all groups, neutralizing alternative explanations. When researchers need to manipulate more than one independent variable at a time, they construct a factorial design. This specific setup is necessary to test interaction or moderation effects, revealing whether the outcome of one variable depends entirely on the presence of another. Strict causality does not occur naturally in the wild. It is a highly controlled state, relying entirely on the active combination of manipulation and randomization. This sliding scale illustrates the fundamental limitation of all research, an unavoidable trade-off between experimental control and realism. Moving left brings us to lab experiments. These artificial settings provide maximum environmental control, isolating variables for the clearest possible causal inference. The downside of this control is low external validity. The artificiality of the lab means your findings might not generalize to actual human behavior and society. Pushing the scale to the right brings us to field experiments. These occur in natural, real-world settings, offering exceptionally high external validity. The cost of that realism is logistical complexity. Field experiments are time-consuming, filled with environmental noise, and require deep cooperation with host organizations. Digital A/B testing operates as a highly specific, highly scalable subset of the field experiment. Because it processes millions of users at once, this scale enables researchers to detect microscopically small effects that remain invisible in a traditional lab setup. By utilizing this scale, A/B testing provides the strongest modern mechanism to replace subjective business intuition with hard causal data. Ultimately, researchers select their method based on whether the specific problem requires high internal control or absolute realism. Internal validity is the absolute confidence that variable X, and only variable X, directly caused variable Y. This table outlines specific threats to internal validity. Field experiments don't automatically possess strong internal validity, and hidden variables can quietly corrupt data. First is history. These are unexpected outside events occurring during the study that artificially alter results. Maturation occurs when participants naturally change biologically or psychologically over the experiment. The testing effect shows how simply taking a pretest artificially changes awareness and subsequent behavior. Selection points to flaws in participant targeting that ruin comparability before the experiment begins. Mortality, or attrition, is the danger of participants dropping out midway, unbalancing groups. Statistical regression is the natural mathematical tendency for extreme starting scores to move closer to the average over time. Finally, instrumentation is where the measurement tool or human observer subtly changes. Outside of this matrix, experiments also face internal threats from participant noncompliance and spillover effects, where treatments leak across test groups. True experiments are built to neutralize these variables. By contrast, quasi-experimental designs lack strong comparison groups, leaving them incredibly weak against these exact threats. If you claim causality without actively controlling for these specific matrix threats, your data-driven conclusion is mathematically compromised. Let's pull back to view the entire research architecture. The full pipeline begins with the qualitative inductive loop, which connects directly into the rigid experimental testing chamber. True insight requires passing through both phases, extracting the meaning of human behavior through inductive exploration, and then surviving the deductive gauntlet of experimental validity. Across this entire pipeline, researchers must actively defend against two critical fail points. On the quantitative side, proper randomization is absolutely non-negotiable for securing internal validity. On the qualitative side, deep context and human meaning cannot be skipped just to get to the math faster. The practice of research lies in the architectural discipline of choosing the precise tools needed to navigate the inherent trade-offs between control, realism, and meaning.